Yay!
Yay! All right, here's a slightly different energy problem, but it's a good illustration of the technique that we use when we use these energy equations. Let's suppose that we have a little rock or an object or whatever at 5 times the Earth's radius away, 5 RE away from the center of the Earth, and we're just going to drop it. So it starts from rest, is what I'm saying, and so it falls towards the Earth. How fast is it going when it gets to 4 times the Earth's radius away? Okay, so this sounds like it's going to be an energy problem, sort of like what we've done before. So let's just go through it real quick and solve it. So again, what we're going to do, here's our energy initial, and our energy final is at that point. And so we're just going to say that energy is conserved between those 2 points. So what happens is that you lose gravitational potential. In this case, we're getting closer to the Earth, right? More bound. So the gravitational potential gets more negative. And as we lose potential, we gain kinetic. Just like in the problems we did in a unit long ago. We're just going to solve for the kinetic energy then, and then the velocity. Okay, so EI equals EF. So that means, what's our initial energy? Well, it starts from rest. We're just dropping it. So that's just going to be minus, it's going to be 0. I'll just write that in explicitly. GM over 5RE. That's where it starts. That's its initial energy, right? And then its final energy, it's got some speed now. This is what we're going to solve for. 1/2 mv squared. And then minus its gravitational potential at that point. GMEM over 4RE. Remembering your negative signs. These always have negative signs. All right. So now, well, I can. It doesn't matter what the mass of the thing is, satellite, rock, whatever. Well, now I can solve for V. That's not going to be too bad. So V is just going to be, let's see, if I move, what am I going to do? I'm going to move this thing over, so it's going to be GME over 4RE. Oh, this is going to be V over 2, right? Let me just do one step at a time. Minus GNE over 5RE. There we go. So collecting all those terms. So it looks like, I mean, that's pretty much 2GME over RE. And that's just a fourth minus a fifth. Right? So a fourth minus a fifth, what's that? That's like 5/20 minus 4/20. It's 1/20. So this is going to be 1/20. So there we go. That's it. I mean, I can go ahead and cancel 2, right? So this is just going to be, oh, sorry, that's V squared. So it's going to be GME over 10 RE. 10 times radius of the Earth. Okay, so, oops, I forgot my 2, didn't I? Oh, no. I canceled the 2 out. Okay, so now we can just go ahead and take the square root. So our V is just going to be the square root of GME over 10RE. There we go. And if you plug these numbers in, we know what these numbers are by now. Mass of the Earth is 6 times 10 to the 24th. Radius of the Earth is 6.4 times 10 to the 6th. Plug those numbers in, which is the boring part, and then what you get out at the end is about 2,500 meters per second. There we go. So that'll be the speed of this thing when it reaches 4 RE away. And that's it. So this is a fairly typical example of energy problems you might run into. You always do it the same way. You calculate the initial energy and the final energy. And the thing to watch out for, the biggest stumbling block for people, is just remembering those dang minus signs on the gravitational potential.